All right, the second of these review integrals is, well, it's my 8x in the numerator. Now notice, in this case, this is no longer tangent inverse. Tangent inverse form has a constant in the numerator. This has a variable, x to the first power, in the numerator. So this is an ordinary u substitution because the degree here is 1, whereas the degree here is 2. And so if this is degree 2, this is 1 degree higher than this numerator. So this is an ordinary Calc 1 problem because the degree differential is 1. If the degree difference is 1, that is an indicator. That's a red flag that should go up and say, this might be a chance to do an ordinary u substitution. You can hand this off to the Calculus 1 part of your brain, and you're going to be good to go. So let u equal, what's the rule? The rule is the larger of the two degrees, either 8x or x squared plus 16. This is the larger degree. Find the derivative. Now, we need to create whatever is left over, and whatever is left over is 8x dx, and that's not what I have. I have 2x dx, I want 8x, so don't we have to multiply both sides of that equation by 4. So this implies that 4 times the left-hand side is equal to 4 times the right-hand side, and that is exactly what we wanted it to be. So, substituting what do we have? We have 8x dx. What is 8x dx? That translates as 4 du. That takes care of everything in the numerator, so the only thing left in the numerator is 1. When everything vanishes from the numerator, we leave a 1. And then what is this? This is x squared plus 16. That is u. So this is equal to 4 times the integral 1 over u du. That's the natural log form. This is 4 natural log absolute u. Now, what was u to begin with? U was x squared plus 16. And again, notice this can never be negative. This can never be negative. Remember the argument from the previous video. And so this is, we could write this as absolute x squared plus 16. And as far as I'm concerned, that's more than wonderful. If you check with the textbook would say this can never be negative, so you don't need the absolute value. So I don't care which of those you would use, they're equivalent in this scenario, so that, or any scenario, they're equivalent here. So either of those is sufficient.